Hi everyone, Ian here. Today we're going to be setting up Raspberry Pi OS Bullseye for Python development. Now I'm going to be doing this from scratch with a brand new install. I have Bullseye here with all the updates ready and installed at the time of recording. And Bullseye is the most recent release of the Raspberry Pi OS, which came out earlier this month. And specifically, I'll be doing this on my Pi 400, which is feeling very lonely after having not got much use since I bought it last year. But the instructions that I'm showing you here should work for any Raspberry Pi running Bullseye. Now, out of the box, Bullseye is fully configured to get started programming Python. And we have, if we look on here, we have a couple of IDEs already. So programming IDEs in here. So you might be asking yourself, why do I need to do anything at all? Or why would I do anything at all? So for me as a Python developer, I have a few preferences on the tools that I use for writing code. I'm already familiar with them, so I want to continue to use them. And additionally, I want to be able to manage multiple versions of Python and the libraries that are on the system within environment simply and easily, and update them when I need to. And this isn't how a Pi or the Raspberry Pi OS, their typical use case for it. It's mostly used for education, and Pi OS is shipped with everything we might need installed globally. So we have a version of Python, and we have a version of a bunch of libraries as well. So we could have, we could decide to use different versions and switch out the micro SD because obviously we have that option. We can switch in and out micro SD cards. That's kind of complicated and a bit more cumbersome than being able to switch between virtual environments on a command line. And I find it's really important to be able to separate these dependencies cleanly when I'm programming. So I want to do it on Bullseye as well. If we carried on using everything in the global version of Python and trying to, in fact, let me show you what's installed on the global version of Python before we get into things. So if we take a look here and have a look at the version. So we've got 392 is the version that we'll get. The most recent version of Python at the current date, which is 26th of November, is Python 399. And we can do the same with Git as well, if I can spell. And so it's 232 for Git, and so the latest version of that is 234.1. There's not massive major differences between Git versions. If we were using the older Buster builds, then we would have Python 2.7.16 and Python Python 3. So we would have 3.7.3. And so obviously Python 2 is unsupported as of January 2020, and so the default version on here, so our Python 3 will also go back to 392 there, as you can see. So yeah, if we look at what pip gives us as well, we can freeze all the modules that we might have. And it takes a little while to pop up here on this little low spec machine. But we can see we have all these global dependencies, or global libraries installed, and if you were to do this on another system, you were to do pip freeze, you actually wouldn't find any of this stuff. It would just be completely blank and it wouldn't have anything installed. So this is somewhat different to other systems, say on a Mac or perhaps on Windows. You can see we've got things like requests and Flask and all sorts of stuff installed. And we might want to install more stuff than that for our dependencies anyway, but the problem we then get is that we are kind of bound by these versions here. And so if we were to try to change any of them, if you're a developer, you're going to understand this, that we might have an impact on some of the other libraries that we have installed. And so we get into this problem of we might end up with conflicting versions of libraries trying to install their dependencies. It gets very messy. And so it makes it really difficult to work on multiple projects that would have different dependencies. So I want to be able to manage multiple versions of Python and the libraries that are installed within it. And so therefore I want to be doing this on, as I said, on the Raspberry Pi as well. So the first thing I want to do is install Pyenv. So if we go to the Pyenv's website, and I can show you what, so you can see, this is literally the first time it's been run, I'm still getting the Raspberry Pi page. If you look for Pyenv on GitHub, and Pyenv is a tool to be able to allow us to manage multiple versions of Python on our machine. So if you want to install Python 3.10 and Python 3.11, say, we can do that if it exists in Pyenv's little repository. So if we look at this, first of all, and I've been through this already and hit some issues, and so the first thing you need to do is install the prerequisites for Python build. So if you go to here, which gives you a collection of libraries that we need to install on Ubuntu, Debian, and Mint, or Debian. That's the same for on the Raspberry Pi as well. So if we start by installing that, and it'll ask us if we want to install, we do. And so this is so we can actually build Python if we need to. So we have a few dependencies there. And then if we come back here and head back to the main, so we're going to do a basic GitHub checkout here. And because we have Git installed, we can literally clone the repository to where it needs to go. So it couldn't fetch some stuff. So let's try sudo apt-get update and see if there's anything it has. Let's try what we had before. See if it's happy. Okay, cool, that did actually work. Okay, so if we can do a remove there as well, because we've got a package that's no longer required. Okay, cool. So if we now clone the Pyenv repo to our local system, so this is coming into a hidden folder underneath our Pi user. So this we just pull down everything there. And we can also do this step, which will compile to a dynamic bash extension and make things a bit faster, hopefully. So that works as well. And then finally, we have this section, which talks about configuring our shell's environment. And so this is where I found a few problems for Raspberry Pi. So the thing that we've got several different versions here, and actually if you look through them, there isn't one for Raspberry Pi OS, because obviously they assumed that people who are, the fact that this device isn't designed for developers, that it's likely that Raspberry Pi OS isn't going to be a common one for people to use. Anyway, so after much kind of digging around, I've found that the one that best suits us is this, so the one for SUSE Linux, which actually will output some paths to our profile, and this profile doesn't exist by default on our machine, and then it spits out something to our bash RC. So this, when we run it, we won't see anything, and if we now try and open up another tab, we haven't seen anything. But if we go and try and use Pyenv, we haven't got a command found. And what I've found is that actually this profile file that we spit out to is only sourced at the time of logging in. So if I come out and log out and then log back in again, it's not, I'm just doing this for demonstrations. You could have sourced the file as well. Then hopefully, when I pull this open, I'll make this a little bit larger again. And there we go. So we've got Pyenv now. And if we look at Pyenv versions, we can see that we've got a system version, which if when we do Python version, we can see, we know that it's 3.9.2. But what we can do is we can install a new version. We can install 3.10.10 or 3.10.0 for instance. So let's go with that. And I think this might fail because there may be another dependency that we might need. And I'll just check. We'll let it go through so you can see that fail, and we can install that library as well. Now this takes a while, so I'll speed up this point in the video so you don't have to watch a terminal sit for a minute or two. Okay, so that took quite a bit of time, but we see it's finished successfully, which is great. So now I should be able to check my versions. And I have the system version and I have Python 3.10. So what I might do is make a folder here, and I'm going to call that code tutorial. If I can spell, is this? Oh, no, we need, if we are doing multiple folders. So in here, I'm going to use Pyenv to set the local version to 3.10. And we'll see after I've done that, we've got a Python version file, which if I look at the contents of, says 3.10. So when I go Pyenv, which, and Python on the end actually, it will tell me that I'm using which binary I'm using. So we have Python, we're using 3.9.2 there. So the next thing I want to do is use pipx to install Python programs. So I want to install pipenv and poetry for managing my virtual environments, and pipx is the best tool that I've found on the Raspberry Pi in order to do this. So I'm currently in my home directory, and we still have each of those versions of Python installed. So I've kind of gone down a path here and jumped forward a little bit because I made a mistake, but I've come back. But now I'm going to install pipx. So pipx is installed with pip, and we're going to be doing it into the system version of Python here. So if I do pyenv versions, you can see that we've got these two versions here. Just close down this window a bit. And there's bit text. and we want to run this command, so these commands in order to install, and you can see that we're using system version there, and that's where we want to put it. So pipx ready to go. Brilliant. So first thing we're going to install is pipenv. And we can see in here we've got the commands for installing pipenv. We can see that we could do it through outs, but I found that that causes a lot of issues. So you can see that when none of the above is the option, we can also use pipx. So that's what I'm going to do. And what that's going to do is going to give us a virtual environment that we can use. Or it's going to allow us to be able to manage virtual environments. Anyway, so there we go. pipenv has been installed. And if we look at our folder here, and we cd into the code folder that we have, so at the moment we've got nothing in here except for the version of Python. So if I tell this to install a library, and I think I specify the version of Python at the same time, hopefully this will go into a virtual environment with Python 3.10, so it's using 3.10. So let's have a look at this. What do we get? Yes, it's telling us that it's using 3.10. That's great. So you can see it's installing requests there. And then we should be able to run within the pipenv, the virtual environment, we should be able to run Python within that. So if we do pipenv run Python and then version, we should get 3.10. Ta-da! Brilliant. So, and we can do this as well and try and import requests, and that should not fail. But if we say import Flask, which is on the, and I'm not sure if it's up or lowercase, so let's just do both. So we can see we can't import Flask, but actually that's on the global systems. So if I were to cd up and then do Python, and then I think, oh no, okay. So we can import Flask there, and that's because we're using 3.9.2. So 3.9.2 here, which is the system version. Okay, so we're able to create environments with pipenv, which is great, because that's kind of the most common one that you'll see battered around at the moment. There is this other one that I use, which is called Poetry, which I find is really nice as well, and it's much better for being able to publish your own work to PyPy and places like that. It encapsulates even more of stuff than pipenv does, so it kind of wraps up all these commands together, so you don't have to think about a lot of stuff. So making sure that we're not using our Python 3.10 version, because we don't want to install stuff in there. We can see that we're just using system Python, so I'm going to use pipx install and Poetry, and fingers crossed this will work as well. Okay, great. So that's worked. So if we go back into our tutorial folder, okay, and we got these pip files in there. The first thing I'm going to do is, I think actually it's like that, pipenv remove. I'm going to remove the virtual environment because you don't actually need that. I'm just using it, and I'm also going to remove the pip files that we had there. And we've still got this Python version file, so I'm going to be using that one. And what I'm going to do to start is, so just check that Poetry is even there on the path. which it is. That's great. And we're going to start by just creating a Py project file. So we're going to go with a load of defaults here. What do you want here? What's my name? Ian. Okay. Oh, I've done that wrong, but I will go back and change it. So I'm going to change that the Python version there because I did that wrong. I want it to be 310. So if we've got a Py project file, we can see we've got no dependencies in there. It's a bit more verbose about the things that are installed in it than it is in pipenv. But what we want to do is we want to get it to use the version of Python that Pyenv is managing. So we're going to use poetry env use, and then we use pipenv which Python. So this returns, as you remember, as I did earlier, the version of the path to the Python 3.10 version. So it's created a virtual environment there. I think this is still the same. Great. So what I'm going to do now is add requests into that, similar to as we did with the pipenv. Okay, great. So that's worked as well. So now, similar to as we did with, what I'm going to do is poetry run Python. So import requests, which is fine. Import Flask, which is not fine. It's not there. It's great. That's what we expect. And just to prove again with pip, see which libraries are there. We've got far more specified, but we've got the same packages. It's just that we also have the files specified as well. So we can either now on our Raspberry Pi use pipenv, we can use poetry, which is great because we've got two options there that are fantastic options. The next thing I'm going to do is update my shell, because this isn't how I'd normally do things in shell, and actually I'd normally use Z shell, so I'm going to go ahead and install that. So in fact, let's clear this down. And Z shell is just a different version of a shell than bash. So if we do, I think, what is it? I can't even remember what the command is. Is that? Yeah, okay, so we can see that our shell is bash. I'm going to go ahead and install Z shell, and we can do that. It's probably one of the simplest commands I've got in this. So it exists in apt, which is nice. And then actually, I think I can't remember how to change a shell, so let's just quickly look at that. Change the default shell, something like bin shell. There you go. In fact, actually, there you go. Cool, straight in there. Let's just okay, so that should have changed now, and I think that this requires a logout again for me to even get it, and we'll get prompted when we come back in. So let's log out here. Now, when we open up our shell now, we get prompted. So we get an saying that we're not getting ZSHRC. So what we need to do is choose option 0, so actually create something. So if we echo out, so if we in fact cat out our bash RC, because we need to copy in the commands that we've just had added to bash RC from pipx. I'm going to do that here. And I'm not sure if pyenv needs to be there as well. So let's just go in there. Let's in fact, actually, we can check that with pyenv. So we've got pyenv, we don't need pyenv. So you can see we've got this file. We need to add in, we don't need pyenv, but we will need the path. So if we exit that, and something else I want to do is install a collection of stuff called ohmyzsh. So this is something I use all the time, and it gives us some nice tweaks to Z shell. So let's have a look at ohmyzsh or ohmyzsh shell. We want to install it, and we're just going to copy this command. Obviously, you shouldn't just randomly copy commands. You should go and inspect this, but I'm fairly confident that there's nothing nasty in there. I've already done this once today, so yeah. So you can see our terminal's changed already. What's quite nice is we get some nice commands. So if I cd into our, say, our pyenv, that is a Git repo that we've cloned earlier, you can see we've got the branch of the Git repo that we're using, and we get some nice colored behavior. You can actually, this is able to be themed and things like that. I should probably do a tutorial on Z shell because I really like it. But we also get commands. So if I do git, well, let's try Python. We haven't actually got any history there, so that's the problem. So I do Python -- version, and then I do Python and up, and it automatically adds like this stuff. So it gives me the history of the Python, which is kind of nice. So we get a whole bunch of stuff with ohmyzsh. You should check out the website, more details on why you want to be using that. And you can actually get themes and things, which is beautiful. So I'm going to just close that and open this again. So let's just check that we've got pyenv, we've got pipenv, yes, and poetry. So all the stuff that we just installed, fantastic. And the last thing I want to do is get set up with an ID. Now, so I mentioned at the start that we got some IDs here, but I'm not familiar with them. So I want to install something that I am familiar with. And in this case, it's going to be Visual Studio Code. And to do that, we just install it using apt. So sudo apt install code. Now, there is other IDs that are available. So there's also PyCharm. PyCharm is quite an unwieldy beast. Code does install a load of extra stuff as well. So it's installing effectively like a whole Chromium instance underneath it. PyCharm also installs like a full JDK and is likely to be incredibly slow on Pi, so I would advise against using it. So that's installed fine. And if we nip up here, now we have Visual Studio Code. Let's pull that open. And the nice thing about Visual Studio Code, or one of them, is that we get a whole bunch of extensions that we can use. So I'm going to go ahead and install the Python one, because obviously that's what we're doing here. We're configuring our little Raspberry Pi to be fully Python featured. So last time I did this, it took a little while, so we just wait for it to finish. And while that's going on, I'm going to get some code in order to demo it with. So I've been using the Code the Classics stuff recently, which is kind of nice. So it's from the Wireframe magazine that the Raspberry Pi Foundation are involved with. So Wireframe Mag GitHub. Is it that one? Code the Classics, there we go, that's what I want. And so I am going to go off and just pull this straight down now. So we can use this as a demo that things are working correctly. So if you do git clone and then the repo that I've just copied. And then again, you can see we've also got git repo here. We can see if we've got any other branches. Poke around in there. No. Okay. So this is basically a collection of games that for like tutorials that you can go through in a brilliant book called The Code the Classics. I'll put a link to that in the description. And they go through old computer games and how they were built and show you how to build them yourself. So let's open the terminal in here. And you can see it's already detected Python 3.10 here. So it might be interesting how, and the first thing I do is just go off and open the Code the Classics folder. And actually, let's do this one. So we're just going to do the first game, which is Boing. I trust the authors of this folder. They're lovely people. And so we can see here that it's importing PG0, which is all on the Python. It's checking from Python 3.10, but what we actually want to use is the system Python, because we want to use a load of, so we can switch that. And what I'm going to do here is run this, and if we are lucky, it will hopefully run it correctly. There we go. That's running nicely. So we get this nice game of Pong here. But it's only just basically showing that we can run Python code. Anyway. Oh wow, I actually beat the computer. That has not happened before. Anyway, I was going to go through this Code the Classics book in another tutorial, so please he's now beating me. It's just AI. Anyway, let's come out of this. So you can see we can run Python. We've got Python versions, and we can also check those versions in here as well. So we can see all those things within a nice IDE now. This IDE, we can install a whole bunch of extensions if we want to. We've got Docker and all sorts of things in there. I've just set this up for Python today. And we have a full dev system available to us, ready to tackle any project, which is really great. No longer are we tied to the default Python libraries that have been installed, although we've been using them in that Boing game there. And we get to be able to play with any version of Python we want to use, and be able to switch between them locally. Now, if you're interested on how you might use some of the tools I've shown here, like pipenv and Poetry for managing virtual environments, then check out some of the other videos on my channel where I use a Mac to demo them in more detail. I also have a couple of hardware videos with the Raspberry Pi, which you might want to take a look at too. If you enjoyed this, then please give it a like and consider subscribing to the channel. It'll give me an idea of what sort of videos to make more of in the future, which really helps me out. Let me know if you found this useful in the comments, and I'll speak to you soon in the next video. Okay, bye for now.